Hey everybody, hope you all are doing well. My name is Laney Shaughnessy. I will be your host this evening. We missed last week. I forget what I was doing. I was tied up somewhere and we didn't have a class last week, so thanks for joining me this week. I appreciate that. I have been asked to create or see if I could make a beehive. Basically a Langstroth style beehive box. And the customer, when he heard that I had a CNC machine, it's not a customer, potential customer. When he heard I had a CNC machine, he was like, oh man, I'd love to see that thing work and all, because I told him that, I have what's called a joint maker jig where I can do finger joints and dovetails and all that stuff. And the box has these finger joints and everything. And I said, I think I could make that box fairly easily on the CNC. And then he's like, oh, and, hey, here's my logo. And I said, oh yeah, that could be either laser engraved in or it could be carved in, because he paints his boxes and all. But I told him I would come up with I would design it. I would make one. See how it goes as far as production wise and everything, see if it's worthwhile, and then I can show him, have him come over and I can show him, which I'm going to end up filming and everything. But I wanted to see if I could do it on a CNC, because it is basically, let's get over to the other computer screen and bear with me just a minute. Okay, we'll pull up this. And we are on screen number 3. Camera 3. Throw me down in the bottom. Where am I at? Okay, so basically, I guess from what I'm taking, I'm not an apiarist. Apiarist is a fancy term for a beekeeper. I don't know anything about beehives or beekeeping or anything, but evidently, the Langstroth beehive is kind of one of the most marketable or popular ones that are out there. And they have different size boxes. They got large or deep, medium, and shallow boxes. Well, this particular gentleman focuses on just the medium size boxes. And on the boxes themselves, it's just literally the box and the frames inside of that box. All the other parts he doesn't want right now or anything like that, which I could turn around and make and stuff. So I was doing some homework and let's see here. Let's go back up to I want to get their name right. Maggie's Bees and Beekeeping. So I was reading an article on Maggie's Bees and Beekeeping. Thanks, Maggie, for putting that out there and everything. But she had kind of a good article with kind of a step-by-step instructions on making the different parts of, the box. I guess this is called, what's the bottom called? I don't know what the bottom's called. Let's see here. It is called the bottom. The bottom board. And then the hive body, that's what I want to focus on, the hive body and their finger joints and stuff. And then the frames. The frames is another thing that I want to focus on and make the frames. Now, the frame parts, especially the sides and everything, and unfortunately there's no way to kind of zoom in and everything here, so hopefully my mouse will circle this well. But the sides and all, they're about 3/8 of an inch wide, and typically what people do is out of a 2x6, they will cut the notches for the top part of the side frame and the notches for the bottom part of the side frame and everything. And then they'll run this 2x6 through a bandsaw, ripping these frame sides down to 3/8 of an inch wide, and they can rack out a lot of them using a table saw to do the notching on both ends, and then a bandsaw or table saw to rip this 2x6 down into 3/8 of an inch sections to come up with the frame piece, which would be these little side pieces here. And so, man, that way you can just batch out a bunch of them, right? Doing them on a CNC, it's a little bit different. When we go into the Vectric software, out of a piece of 1x6, I've got all 4 of the frame pieces, the vectors, laid out here. We're going to talk about them and stuff. But these side pieces here, like I said, they can do the top notch and the bottom notch on a 2x6, and then they can chop that 2x6 into 3/8 inch pieces, and they got like hell, almost a dozen or more side pieces, right? Versus me here out of one board, I've got one frame out of one small board, right? So as far as batching and everything, doing it by hand, much faster, I think. I think it'd be much faster. I think it'd be much more productive. I don't know. But I want to show the individual that I can do it, or that it could be done on the CNC, and things like that. And so we got the frame parts, but the box parts, I want to do the finger joint jigs and everything with you. And we're going to go through that. So I want to kind of take you through that process. So hopefully it's something interesting. And when it's all said and done, we have a bunch of frames and all that cool stuff. And who knows, might be a beekeeper one day. But what I found out is the guy's like, man, if you could make them, I would buy them from you. I go out and I buy them on eBay or Etsy or this or that, and sometimes they just don't fit really great together and all this stuff. And he's telling me all the negatives of him having to go out and buy it. It's kind of too. He doesn't have he's got a little table saw, all this, that, so he can't make them. He can, but it's easier for him to go spend a couple $100, and he'll spend a good amount of money, but they are together. So it could be an avenue of all these apiarists out here looking for Beehive boxes and all. It could be an avenue of revenue, right? And I said, well, let me see what I can do. Let me see, production wise and everything, because I know on a table saw and a bandsaw, I could rock these out. It's super simple. My box joint jig on my table saw, the notches, ripping the pieces down, dado blades, bandsaw, I can knock it out, no problem. I'm a woodworker, that's what I do. But I want to do it on CNC, and I want to kind of compare and see if it's something that I could just throw on the table and knock it out. Right? Who knows? I don't know. We'll find out. And you're going to go on the journey with me if you stick around through this. And you can ask questions about anything. It doesn't have to be about this. If you have questions about the Vectric software, go ahead and ask. One of the things that we're going to be using is going to be called a finger joint gadget. And if you go up into your gadgets tools, and desktop users, you don't have access to gadgets, unfortunately. I apologize for that. But VCarve Pro and Aspire users, you do. And you'll notice in my list here, I don't have the finger joint gadget. The finger joint gadget was created by a young man, and he's got a video on it, and I'll be damned if I can't remember his name. I want to give him credit where credit is due. Hold on a second. Let me finger joint. me see if I can pull up the files. Maybe his name will pop up in one of them while we're doing that. We're not going to wait on that. We'll come back to it. I want to give him proper credit because he created a cool little gadget. And I don't have the finger joint gadget in my Vectric as of right now. So step number one, we need to add the gadget to our gadget library. So I'm going to take the finger joint gadget folder. Here, the folder, and inside of this folder there is the style sheet, there's the Lua file, and then there's a HTML document. These three things together are going to create the gadget for me in Vectric if I drop them into the correct folder. So I'm going to take that folder and I'm going to copy it, and I'm going to go to the C drive. I'm going to go to Users, Public Documents, Vectric Files. And in the Vectric Files folder, I have a Gadgets folder here. I'm going to go into Gadgets, and then I want to make sure that I'm in my appropriate folder. You're going to most likely only have, you might have all your VCAR of 9, 9.5, 10, whatever you've got. I have all the software, so I just need to make sure I drop it into the right folder that I'm working in. I'm working in the VCAR Pro 11 here. And in the VCAR Pro 11, I just want to paste that folder. And I want to come back over here, and on my Beehive frame, I want to save my work because I want to, kind of exit out of the software, and I'm going to restart it. And let's go back into the VCAR Pro. Where'd you get the gadget from? Well, it's free, Kool-Aid, and I'm going to put it in the description of the video for download. It's free disbursement. You can get it offline, the Vectric forums and stuff, but I'm going to just go ahead and provide it. You'll be able to download it from the description of this video and everything, the folder and stuff, because it's out there in the public. It's not something that I can't share or what have you. It's not a purchase or anything like that. So we'll download that in the description of the video. It'll be there and stuff. So now if I go back into my this particular file, we got to create our frame file. This particular file, if I go back to my gadgets, I should be able to see the finger joint gadget here now. And so we have successfully added a gadget to our gadget library. And that's how you would do it. You would go to the Vectric gadget library, and they have things like the dovetail gadget, the box making gadget, the spiral gadget, and things like that in the gadget library. And basically, under gadgets, to get to the gadget library, you can go to About Gadgets, and vectricgadgets.com down at the bottom, or gadgets.vectric.com, and it's going to want to open for some odd reason in my Internet Explorer, and I don't use Internet Explorer. So what we're going to do is we're going to grab that URL and copy it from there, close that out, and I'm going to go into Google, because I am a Google guy, ladies and gentlemen. We're going to paste and go there. All right, so in the gadget library, they've got drawing gadgets, modeling gadgets, Toolpaths, and things like that. With regards to the drawing gadgets, circle resize, flute gadget, gear maker, spiral gadget, square to round, square around, square around, and valances. They've got some modeling gadgets like the box creator, chamfer, dados, dovetails, halftones, and things like that. And some of these are old. Some of these are now actually built into the latest and greatest of the software and stuff. And some of them are not and everything. But like the Chamfer Gadget is, dog bone fillets. We have a fillet tool where we can do fillets and stuff. But, things like the box creator and the dovetail gadget, those are pretty cool and stuff. But we would do that. We would download it, the folder, we would unzip it, and then we would drop it into the C drive, users, public documents, Vectric files, and then in the gadgets folder, make sure you're in your appropriate, version, and just drop it in there. Once you do, it's in there. All right. So we're going to get back to this in a moment. I want to kind of start fresh. I want to build the actual box. I haven't done any of the pre-design on that one. This one I did because I was just practicing with the layout while I was waiting for tonight's class to start. And so we're going to start with a new sheet. Add a new sheet, and I'm going to call this the medium hive box. And the I'm going to go medium hive box sides and then front and back. So let's make another sheet. I'm going to call this medium hive box sides. And then the other medium hive box I'll call front and back. Front. Back. Now, if you don't have version 11 where you have these new sheets where you can create multiple sheets in one project, then you just simply create an individual project for each of the corresponding items, right? All right, so I'm going to go into here and I'm going to illustrate and draw my joint maker jig that's on my table so you have an idea of why I'm creating the finger joints in the way that I do. Now on each of these boxes, I know that the customer thought it would be cool to have their logo carved in the Beehive, and everything, their honey logo or whatever. And so we'll end up doing that. But there's also these handle type notches in the, let's see if we can go back to the illustration here. And let's see if we can see that. So I don't know how well it shows up on the screen, but you see that big old notch right there? And I wish I could zoom in. Here, I can do it this way. Rectangular. Oh. Oops, hold on, cancel. Are you not gonna let me? You're such a goofball. Okay. I don't know why I'm doing it this way, but hey, I'm doing it this way. All right. Now I can zoom in. Okay. So there's these handle notches. And if I'm not mistaken, they're on all four sides. If I look at the picture of the hive, I can see it on these two sides here, so I'm almost 100% certain they're on the opposite two sides as well. If I look at, the pictures here, I can see it's on two sides, so assumption is it's on all four sides, right? These little notch handles. So we got to make those and stuff too, and everything. We'll figure out how we're going to do that. But let's get back to our design. All these windows. And so there's that. But I'm going to be working on the end of my table to do the finger joints. And I could work on the table, and I could do the finger joints on the table, but I would have to do fillets. So we'll look at that way as well. Okay. I don't know if the fillets are going to be appropriate, because I was explaining that to the customer that, you know, I could carve the finger joints on the table, but I would have to have some kind of relief for the router bit, and it would create these little fillets. And so when the joints are together, you'll see them. And he wasn't too keen about that. He's like, nah, I really like it to be clean, you know, clean finger joints and stuff. So that means that I have to do it on my joint maker jig. Now, if this were my CNC here on the screen, let's say that my gantry and router, fancy. All right. We'll even make a little stand there. Okay. So if this were my CNC here, my CNC has the ability to travel to where the bit can travel up to 3 inches past the front of the table, so that I could carve off the front of the CNC. And because of that, we have a jig called the Joint Maker jig, which comes off the table here and here. And it allows me to clamp boards of different lengths up to about 36 inches long, because my table's only so long and everything, so I can't go like 8-foot boards or anything like that. But it allows my router and everything to be able to come in and, you know, cut on the end of that board and stuff. So I can come down and I can cut those finger joints and stuff, you know, and everything. So, you know, whatever they may be. And because of that, I should be able to, I don't need fillets. I can just get a nice clean finger joint, dovetails, finger joints, what have you. And because of that, imagine, if you will, that, you know, on our screen, our computer screen here, our x-axis is the length of the table, and the y-axis is the height of the table. Okay. And if my board was clamped on the end of my jig here, and it's 3/4 of an inch wide, well, on my X in my design setup, my job setup, it's going to be 3/4 inches wide. My width is going to be however wide the boards are. In this case, they're going to be 6 5/8, because that's how deep the box is, 6 5/8, and the medium-sized box. So I'm going to have 6 5/8 inch wide board, so that'll be my Y in my job setup. And then the Z is just going to be whatever. I'm going to probably go 3 inches or at all, and that's just so I can get a realistic view of the end of the board that I'm going to be looking at. So in our job setup, let's move this off to the side here. We'll move that off to the side. In my job setup, I'm going to have my medium box hive sides, my medium box front. That's so I can do the handles, right? The handles. But I also need to create the box ends, right? So I'm going to have my box side ends and my box front back ends, you know, end, right? I'm just going to call it the end. So I need my box sides end, and I need another sheet for my box front back ends, right? And on those, on the setup, okay, the width is going to be 3/4, because that's how thick my material is. The height is going to be my 6 and 5/8, 6.625. And then the Z is just going to, just so I have a realistic end view and everything, I'm just going to go 3 inches. That number's irrelevant at this point. When this is, imagine my table's over here, right? And I'm carving my finger joints in this board. We're looking now kind of at a top view down over the table and everything. I'm going to be zeroing out on the outside Y minus corner, so the bottom left corner of the board. So my bit is going to come out and it's going to zero out on that outside corner of the board. And so that setup is good there. I'll go ahead and click OK. Now, now that the box is, the joint, or the box is laid out appropriately and everything for how it's going to carve, now I need to create my finger joints. And I could, you know, I could come in here with rectangles and I could create, you know, the rectangles where my finger joints are going to be and everything. And, you know, I could create, I don't know why I'm freehand drawing all these boxes. That's pretty stupid. I'm going to hold down my control key and drag out 1, 2, 3, 4 will be fine. Now I want to kind of space these evenly. So if I were going to do that, I would take a rectangle and I would draw a rectangle around the perimeter of my end piece, right? Quote, quote, end piece. I would select my 4 boxes here. I would hold down the shift key. I would select that rectangle that goes over the perimeter of my board and I would align them to the center, and then I would space them equal distance, you know, to create my, you know, my tails. And then opposite of that would be my, you know, my pins, if you will, you know, for the finger joints or what have you and stuff. So I could do that. And then it would be, you know, one would be my tail board, one would be my pin board in a sense for the finger joints. But the finger joint gadget that was created is a pretty cool tool. The only problem with the finger joint gadget is it will not create my finger joints properly with my board in this orientation. This is the one flaw that I hope the gentleman goes back one day and fixes. It's the one flaw that that I found, that, you know, because of the setup. And let me show you what I mean by that. So I'm going to delete these boxes here and I'm going to go into the finger joint gadget. Okay. Now on the finger joint gadget, it's going to ask me how many pins that I want. It's going to ask me the width of my pins and then my end mill diameter, the bit that I'm using, my clearance, and then the passover. We'll talk about the passover in a moment. And I have 2 choices. I can do a divided cut where it cuts halfway through the board on one side and halfway through the board on the other. That eliminates tear out. That's what I prefer. Or a pass-through cut where it just actually passes all the way through from one side to the other. If you're going to do a pass-through with the finger joint jig or gadget, then you need some kind of backer board to prevent tear out, blowout, you know, and stuff. I like the divided where it cuts half, and then on the other side it cuts half, and I get a nice through cut. But let's say, just as an example, I go 4 pins, and the width of my pins are, let's go 5/8 for now, and I'm using a 1/4 inch end mill. The clearance, 5 thousandths clearance is good, but I want on my passover, I want to go at least slightly under the size, the diameter of the bit. So I'm going to, for me, it's going to just be 2.375 instead of 0.25. And when I create the finger joints and everything, based on how my board is set up, it creates them incorrectly. So this is not what they're supposed to look like. It does create layers for me, right? So I have my socket layer and my pin layer and everything, but they're incorrect. Okay, so the reason why is because the gadget only works. It's basing those on this cut, but it only works when the board is facing along the x-axis. Along the x-axis. So I have to turn the dimensions of the board around, create the finger joints using the gadget, and then rotate everything 90 degrees. Okay? So let's go ahead and go into the job setup for this sheet. Make sure we're on this sheet. Go into the job setup for it, and I'm just going to turn things around. So this is going to be 0.75. This is going to be my 6.625. Okay, so we're looking at it like this now. Okay, so now I can go ahead and I'm going to go ahead and delete those two layers that were created by default by the joint maker jig, or the finger joint jig. And we're going to do it again. Gadgets, finger joint gadget. I'm going to go 4 fingers, or 4 pins, interior pins. My end pin width, I want 5/8 on each end. I'm going to use a 1/4 inch end mill. The clearance is going to be 5 thousandths. I'll show you where that is. And then the passover is going to be 0.2375. When I create the finger joints, we'll have this here. Okay. Now, let me center this on the board. Okay. Let's take a look at the two different, we'll start with the socket board and the pin board first. So let's turn off the pin board. Let's look at the socket board. So these are the sockets. So this rectangle here is going to be one pocket cut, and this one here is going to be the other. So that's that divided. And that overcut distance, the space right here, that's that 0.2375. So the bit is going to come in and cut this side, this side, this side, all the way down, and then it's going to come over and cut this side, this side, this side, this side on the other side, just so I don't get any tear out, instead of just passing straight through. Now, the socket board, or the pin board, is opposite of that, right? So I've got my sockets on the outside, my pins on the inside, and the same thing. I've got the 2 rectangles where those pockets are going to occur. Okay. Now, the 5 thousandths of an inch clearance and everything is that this clearance here. So when it's cutting and everything, it's overlapping. You know, it's overcutting by 5 thousandths of an inch. So I got a nice, good fit, and it's not too tight. If there's no allowance, then I'm going to be beating that thing in, you know, and stuff. And I want a nice friction fit, you know, and 5 thousandths should give me that. Should be okay. Should give me that. If it doesn't, then I reduce it down, you know, reduce it down. But let's create the toolpaths, and then we'll look at that, and then I'll show you what we got to do for my particular setup. Everything's got to be rotated 90 degrees. And so we will start off with the socket board. We'll select the individual pockets. It's going to be a pocket toolpath, and my material is 3/4 of an inch thick. Okay. It is, when I put the fingers together, I want them to be a little bit proud. Okay. That way I can sand do a nice sanding on the outside and sand those fingers perfectly and stuff. You know, they don't need to be too proud, but, you know, just slightly proud. So, on my cut depth, I'm going to go just an extra 10 thousandths of an inch. So I'm going to go 0.76 on my cut depth. I'm going to use a 1/4 inch end mill. And currently right now, my end mill is taking 1/8 of an inch per pass, and that's fine. So we'll go ahead and calculate that toolpath. Okay. And let's turn this way. Now you can see why I go with a 3 inches just for an end view and all. But let's simulate this. So, and I'm going to slow it down just a little bit. When it cuts, it's going to pocket out the side with that 0.2375 passed over. So it's passing over the halfway mark on each side. So it's going to cut through. And so now that we've seen, you know, the first couple of pockets, it's going to go through and excuse me, I got a frog in my throat. Those Bang drinks are good. But it's going to cut the fingers on the that side, and then it's going to start the other side and work its way back. This is going to prevent tear out for me and everything, and it's actually much faster. It does pretty fast. But that if I wanted to do just a straight pocket and then down, you know, all the way through, pass through, then I want to make sure that I have some kind of sacrificial boards at the bottom here so I don't get blowout. I want nice, clean, you know, this person, that he's very particular about his hives, you know, and stuff. And I've seen a lot of people that are, they really want their hives looking great, you know, and everything. I guess the bees need a nice house to live in, and stuff, and all. But so I want to make sure that it's clean, no tear out, right? So I could do a pass through, but I would make sure I have sacrificial boards there to prevent that blowout. Or I'm just going to do the divided cut such as this, right? Either way. And the once the socket board toolpath is completed, then the pen board turns on. Same thing. We go into do a pocket cut, 0.76, our end mill, offset, and continue, right? So that will, I'm going to turn off the animation, and I'm just going to let it run through its course. Preview that toolpath. So it'll take a second. And while that's going, I'll answer a question. How would you import an STL file into the library folder of clip art file so you can see it for a Spire? Jim, you can't. An STL file is a third-party model file, and therefore it will not show up when it's imported into the clip art folder of Vectric. The Vectric clip art folder is for V3M files, V3D clip files, all the Vectric native Vectric files you can put in your clip art folder, and you can see them in Vectric when you're in your clip art tab. STLs, OBJs, .x, .3ds, all those other ones that are third-party model files, you cannot put them in your clip art file and see them in your Vectric as 3D clip art, okay? You won't be able to do that. So, great question. And so this would be the, you know, the pen board and stuff and everything. Now, if I were to look at here, the individual in this tutorial, this is a medium box here, and as I look at other pictures and things and stuff, what I'm seeing is, and I can't tell if that's a medium box or not. Let's go back here. The medium-sized box, which is box number 5 here, that's the medium-sized box. It looks to have just 3 pins and tails and stuff. So that, you know, I'm seeing 3 pins, and I believe in this as well, 1, 2, 3. Yeah. So in my case, you know, I went with 4 because, you know, just kind of showing you the layout and stuff, but they're going with 3, and they're much wider pins and stuff. And so that's what I'll do. I will turn the layers back on, I'll go ahead and delete this. And I'll go back to the gadget library really quickly, finger joint gadget, and I'm going to go 3. My end pins, you know, it's asking how wide I want my end pins. Let's see here. 5/8 may not look too bad. Let's create that and find out. Yeah, so that doesn't look bad as far as that goes. All right, let me center that up, and then we'll turn off one, and let's see, 1, 2, 3. Did I not ask for 3? 3 inner pins, interior pins. I've got 3 interior pins. 1, 2, 3, yep. And then my exterior pins. So I need 1 interior pin. No, 2 interior pins. Here's my end pieces. And then 2 interior pins. 2 interior pins. Alrighty. Let's turn that back on and delete that. I knew something was off there. Gadgets, finger joint gadget, 2 interior pins. The wording is right there in front of my face, interior pins. You know, I should have paid attention. All right, cool. All right, let's get that centered on the board. Now, I've got to, before I can create the toolpath, the proper toolpaths and everything for it, I got to rotate everything. So very simply, all I have to do from this point on is I've got to go into the job here, into my sheets, edit, change this back to 3/4. And I have to do this because my machine, my jig is on the end of my machine, which is the end of my x-axis. So I've got to turn it this way. It's required. And 6.625. Click OK. And then I can take the vectors, simply rotate them 90 degrees, and recenter them on the board. Then I can come in and turn off the layers, and I can create the toolpaths appropriately. So this one here, we'll open it up, and this is going to be my socket board for my socket board. Bear with me just a second. I want to make sure I say this right. Let me grab this for a second. Okay, we're not going to grab that. Let me grab one where the picture is a little bit clearer. There we go. Let's see here. The front is should be the socket board. The front is the socket board. So my front and back boards, those will be the socket boards, and then my 2 side boards will be the pin boards. Okay, so the socket boards, and I'm just gonna put front, back, and 0.25 end mill. Oops. 0.25 end mill, and calculate. Continue. Now that box keeps popping up because I have that overlap of those 2 vectors. Their rectangular vectors overlap by that 0.2375. So you're going to get that warning that there's some overlap and everything. And so the that will be my socket board. And now let's go ahead and stop that. I don't need to preview it. Turn that off. Turn the pin board on. This is going to be my pin board. Sides 0.25 mil. And calculate that. Now, the great thing about this gadget, this particular gadget and everything, is it does the allowance and everything for me. The overlap and allowance, between, the joints and everything. I would still test cut and make sure that 5/1000 isn't too much. For me, it's been pretty good, so far and stuff. And, I'm happy with that. Now, if you were not particular about your, the joints and everything, we could very well, let's say that this is my board here. We could actually carve it on the table without having the cutting on the ends and stuff. We would just need to create fillets so the bit has a place to escape. And we're gonna draw that out right here. So let's say my board is 6.625. My width is it's the whole box is actually 16 inches by 19 and 7/8. So we'll just do 16 here. Okay, and so I'll draw a rectangle. This rectangle will be the width will be 0.76. That's how thick my boards are. 0.75. I want a little bit of a 10,000 7-inch overlap, so I get a nice little overlap that I can sand pristinely. So 0.76. And the height on my end pieces, I set my end pieces up to be 0.625. So we'll stick with that, 0.625. And click apply. And so this will kind of represent that end piece for a moment. Let's see here. I'm going to grab a line and I'm going to throw a line right here. That's my center line. Going to take this rectangle, hold down my shift key, take this rectangle or this line, and I'm going to flip. I'm going to use the mirror tool and I'm going to flip it about that line so it's on the other side. Okay. Now, in between here, so if we look at the actual socket board here, in between, I've got two other pocket cuts that are gonna occur to create the these sockets and everything, and they are 1 inch wide. Okay, 1.0765 to be exact on the height. Let's look at the size. 1.0765 on the height, and so you could, let's get back to this for a moment. Basically, if I draw another rectangle, again, it's going to be, the width is going to be 0.76, and the height's going to be that 1.06 or 765. And again, that number comes from here. Okay, 1.0765. But if we, let's resize this, 0.076, 1.0765, click apply. Let's stick that bad boy right here for a moment. and then hold the control key down, and I'm going to drag down a second copy. Now, I want these two right here evenly spaced between these two. Okay? So, because they're vectors right now. Those are, don't consider those being the cuts just yet. But I want those kind of spaced in between those two. And the what I'm going to do that is I have a choice. I'll just draw a line. I'm going to snag a line from here to here. And let's let's do that again, because that line was crooked as all be it. From here straight down 90 degrees. There we go. And now I can take these two objects here. I can select this line last, and I can space those vertically on that last vector to evenly space them. Okay? So it will evenly space them out and stuff. And what we are, if I were to trim away right now, if I were to trim away, let's get rid of this line for a moment. If I were to take all four of these objects and pull this out here, and I'm going to take these two objects, pull that out ever so slightly this way, pull that ever out so slightly this way. If I were to trim these, we would actually be looking at the pin board, not the socket board, right? If I was to trim this and trim this, trim this and trim this, we'd be looking at the pin board, not the socket board, right? So undo that. And what I need to draw is my rectangles for the pin board. So they essentially just go in between the sockets. Okay. And with those, hold down the shift key. I'm going to pull them out just so they clear the board a little bit. And now I have my socket. So now if I were trimming this, okay, and then of course, you know, we've got these overlaps and stuff. If I got rid of them for a moment, and let me trim up some of the, clean up some of my mess. That would be the socket board there, right? So if I'm carving this on the flat table, when that router bit, using a 1/4 inch end mill, when that router bit's coming in and cutting and everything, I'm going to end up with radiuses here. You know, I'm going to end up with a radius here when it's cutting this out, and I can't have that, so the two pieces won't fit together. So the thing that I need to do is I need to create what's called dog bone fillets. The fillets are going to be the radius of the bit. If I have a 1/4 inch bit, the 1/8 inch radius, and I'm going to be putting fillets on these inside corners on each of these inside cuts. Okay. This way, when the router bit is cutting along here, it has a place to go, you know, as it cuts up, you know, the next path. And I can now fit my square peg, my other finger and stuff. Oops. Let me learn how to draw. When it goes in and it seats in there, it can sit nice and flush. Let me back it up flush. There we go. Let me get rid of that router bit circle. but it can fit nice and flush in there, you know, in those fingers and stuff and everything. So we have to have that relief, right? So those dog bone fillets. And when those two joints go together and everything, you're going to be able to see that little relief there, that little bit of a cutout. And to the gentleman that I was working with or talking to, you know, about these and all, he wasn't keen on that. He wants a nice clean joint. So for me, in order to get a clean joint, if I'm going to do it on the table saw or the CNC, then I've got to use my joint maker jig where the router carves off the end of the table. But if I don't have that feature and I need to carve them on the table, then I can still carve the finger joints on the table. I just have to, my sacrifice is the little fillets, right? And they may not be that big of a deal, you know, for most people. So let's see here. Will this work for those of us with a regular CNC machines? Cadley, that's what we're just talking about now is, you know, if you have a regular CNC machine that cannot carve off the front of your table and everything, where, let me get back to one of these boxes is, if your CNC can't carve off the front of the table and everything, then you can still carve that on the, you know, on the flat, right? You just have to create the dog bone fillets so that, you know, that joint will fit together, right? Okay. And the question of the day is, hey, could I use the joint maker jig or gadget, finger joint gadget? Could I use the finger joint gadget and let's delete this. And let's redraw another board that is 6.625 wide. Could I use the vectors that are created from the finger joint gadget, you know, to create what I need to create? You can, you know, let's turn off the pin boards for a minute. Let's focus. Oops. Hold on a second. Let me move this over, copy it over to the pin board and socket board layer. There we go. All right, let me turn off the pin board for a second. So I could use this vector, you know, to create the cut that I need to create, but I won't be using these outside rectangles. So those are gone, right? Okay. And these rectangles, the width of them, the width on the x-axis has to be the width of my project board. So if I go into the size tool, I would have to change that width to 0.76. Make sure I unlink the height. I don't want to change that, just the width, 0.76. And then I could come in and pretty much just snap that into place, and you know, I could lay that out. Now on each and every one of these, once they're snapped into place here and they're the right size, now I can actually drag out one side a little bit further so that I could use my scissors to trim away. Okay. Now my socket board vectors are going to create my pin board. My pin board vectors are going to create my socket board. So you got to get that wrapped in your head too. So we've got that. All right. Now let's go and draw another board here. We'll draw one side by side. Oops. Let's take another board. And again, it's going to be 6.625 inches wide. Okay. All right, let's turn on our pin board vectors. Turn off our socket board vector. Oops. I drew the... Let's move this over. Copy this over to the pin board layer. There we go. All right, let's turn off our socket board layers. And these vectors here, come in and snap them up there. Find my center and stuff. All right, I want to group those together for right now. Group, select this rectangle last, and align up and down on that last item. There we go. Perfect. All right. Once again, let me ungroup them now. U for ungroup, G for group, U for ungroup. I'm not going to use the outside rectangles. These rectangles have to be 0.76. So go to the size, 0.76. Line them up. When they're 0.76, line them up there. Once they're lined up and snapped there, then you can drag out this side a little bit more. That way it doesn't move this side. And then you can trim that up. And that will be your socket board, right? So the pin board here and the socket board, right? So now create the fillet. So, once we have the, once we have the vectors laid out, and we could do the other side too. We could have copied everything over to the other side. So the machine goes over and cuts the other side too, or we could just flip our board end to end and just do both sides on one end of the table, however you want to do it. But we have to put our fillets in there. So on all of the inside cuts, my fillet is 1/8 inch radius because I'm using a 1/4 inch end mill. And, I'm going to come in here and run that cut. Okay, so that would be our fillets that we would need, and then we could create the toolpath. If I created the toolpath on this, let me copy this over to the one of the other sheets. Copy to the front and back sheet. That's fine. Let's center that. Oop, select it first, it would help. And let me look at my job setup for that sheet. Okay, 6.625. And the length of this, that's the one thing I don't know. Hold on a second. My boxes are 16 wide. Hold on, I've got it here. 16 inches wide, 19 and 7/8 inches long. So if this is my front and back, hold on a second. That's my 16. My 16. So 16. Okay. And let me get this. Set up there. Let me pull this. I'm just going to do one side for right now, but if I'm going to do this cut, I do not need my router bit traveling all the way around to do, you know, I don't need it to do a whole outside profile cut on this. And here, let me make it easy visually. Let me go into node editing. Let me cut the vector here and here. Let me delete that and let me mirror this over. Create a mirror copy, flip it to the right. Okay. And back that up. All right. Let me get rid of this overlap. Bear with me just 1 second. All right, so if this was my board, I don't necessarily need my router bit to come and cut, travel down the edge and cut, unless I'm actually cutting it to size. I'm going to be clamping this thing on the table already cut to the 6 5/8 on here. So all I need it to do is my end cuts. And so I'm going to take and go into node editing. And I'm going to take these bottom nodes here, and I'm going to use the down arrow key and bring them down just slightly past the board on this edge. And then these nodes up here, I'm going to go up with the up arrow key, slightly past. And then I'm going to delete the spans on the side. Delete the spans on the side. So all I have are the two end vectors. We have this end and this end. Now the start point is important. When we're cutting, we're going to be doing a profile cut, and we're going to be doing a climb cut. So we're going to be coming up this way and then coming over and coming down this way. So my start points, make that the start point down here, and that one's already the start point up there. I'll be good to go. So cutting 3/4 of an inch using a 1/4 inch end mill. Don't need tabs or anything like that. I will use the start at, keep the current start points. I want to keep the current start points. And the vector selection order, I'll select this side first, hold the shift key, select this side second, and I will use the vector selection order on that and calculate that. And so preview that selected toolpath, and what went wrong there? Big problem there. Hold on. Let's go back and see what could have possibly gone wrong. Cutting on the wrong side of the line. All right, so it started up here on this side for some reason, not sure why, and then down here, and that's not where my start points are. It cut on the inside of the line. So, and I need to be on the outside of the line. So, outside right, it's taking my start point and it's cutting on the outside right when it should be, if this start point's up here, this side's the left side. Okay. This side's the left side, because if I'm looking at it this way, this is my left, that's my right. And then here, this is the left, so I should be cutting on the inside left. Let's calculate that again. All right, reset that preview and preview that visible toolpath. Much better. And if we look at it from the side, the fillets really aren't that bad, but you'll be able to see those slight little half moons or something, you know, when the joints are together. So you could cut this on the table, on the flat. You don't have to be on the end of the table with anything special. You could cut it on the table, on the flat. No problem. Okay. And let's see here. You could always fill in the voided parts with the fillets with something. You could, yeah. And the thing, you know, on it is they're painting it anyway. He's painting it white. So you'd have to fill it, whatever you could fill it with that's not going to hurt the bees, right? So wood filler, right? I don't know if Bondo, I think the chemical in Bondo or something, that might not be a good thing, but maybe wood filler and stuff. But yeah, you could fill that because it's getting painted. It's getting painted white. They're painting it white, so you know, that might talk to him about that just to show him, you know, that you know what it would look like. I might even make one, put a box together and make one and all. Now the fun part, the handle. Okay, so got to figure out the handle situation and everything on this. And the funny thing is I put the wrong vectors on the wrong board. So I'm going to just make it simple on myself, and I'm going to rename my sheets. This sheet here, Hive's front and back, should be sides because this is actually the socket board and everything, the socket board vectors. So I'm going to rename this to box sides, and I'll rename the other one front back. Front back, just so I don't have to move the vectors over to the other sheet and da 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 da. All right, so this board is going to be 16 by 6 5/8. The front and back, I'm sorry, I'm getting myself confused here. Going to sheets. The sides are going to be 19 7/8 inches long. Okay, so let me edit this. They're going to be 19.875 in length. These vectors here are going to move down. Okay, and we're just simply going to recalculate the toolpath. Okay, so that one's fixed. On my front and back here, this is going to be 16 inches, not 106, 16 by 6 5/8. And the vectors, the vectors for them are on this layer here. So this is actually the vectors for them. So we'll grab this. Nope. This one. We will copy that, not copy, sorry, copy to sheet, and it needs to be on my sides. No. Front and back. You son of a gun. Lord of mercy. We'll get it right here. Copy to front and back. All right, let's go back to where we were here. Okay. Well, we'll get it to line up here in just a moment. There we go. And on this end, I'm going to basically just cut this down. So if I'm 16 inches overall length, you know, and everything, I'm just going to go 8 inches. And on this line, don't ask me what I'm doing here right now, but I want to go 8 inches from there. And right at the end of that line is where I want to cut the vectors on this node, on this rectangle. So and then opposite of that, ooh, I better use a guideline for that one. I want to cut the vector there. Okay. That way I can delete this half. There must have been duplicates there. Let's try that again. Cut the vector there. Cut the vector there. Beautiful. Get rid of that half. Turn off those guidelines so they don't confuse us. And I'm going to flip that to the right. I'm always off by just a little bit every time I go to flip. I don't know why. I keep missing the mark on that one. Okay. Node editing. Delete this span. Delete this span. This one. And that one. I'm going to take this, these two nodes right here and just bump them up a little bit. There's another span I got to delete. And I'm going to take these two nodes, bump them down a little bit. Another span to delete. There we go. And now I can create those toolpaths. So once again, I'm going to make my start point down here. Make my start point up here. It's already there. And I've got some other vectors. There's some other geometry and stuff hiding in here. Some extra lines and things that shouldn't be. Wonderful. All right, profile toolpath. Cutting all the way through, 1/4 inch end mill, inside cut, climb, and I want to use the vector selection order, and I want to keep the current start points. Now, there's another vector right there. I want to delete that bad boy. I don't know where all these other vectors are coming from. They're just like everywhere. All right, calculate that up. Wonderful. Preview the visible toolpath. And that should be my socket board. my 16-inch front and back socket board. Okay. Okie dokie. All right, let's take a look and make sure that I'm going to call this my socket board. And again, this is if I was carving it on the table. Okay. Flat on table. All right. Now, handle. This is the last thing I got to do with this, and then basically all the sides are done, is that handle. Now that handle had, you know, I'm in VCarve Pro, so I can't really model it, if you will. I can't model it and everything, but the handle kind of had almost like a dish feature to it. Okay, so it came smooth, and it comes down, and then there's a lip there, right? So it's kind of cut halfway off. So I'm gonna draw out the vector, kind of similar to what I want and everything. And on the handle, I'm gonna go, I think I figured it out a moment ago. I'm gonna go like 4.5 inches. Okay, so 4.5 inches wide, and I'm going to say 3 inches on the height, the little dish and all. So we'll go 3 inches. And this, let me get it centered here. Center. Now, this basically has a the kind of look to it, you know, if it will, is it's kind of a dish in a sense like this. And let me trim this up. Okay, kind of like that, right? And so it's dished out. Well, I don't have Aspire. I can't create that model, you know. I have Aspire, but I'm in Pro, right? I can't create that model. A fluting toolpath might get me there, but not really. It's not going to give me that nice scoop look and everything. So I am going to turn to my clip art to help me with this handle. Or I would use a large cove bit. I could use a cove bit of some sort to kind of come and cove cut it, if you will. But in this instance, I'm going to use a model. And the model that I'm going to use from my clip art is going to be in the domes and dishes category. And bear with me one moment while I go grab some clip art and throw into that folder. Let's see here. C drive, program files, or users, sorry. Public documents, Vectric files, clip art, and domes and dishes. Okay, so in these files here, they're showing up, but they're only showing up in my Aspire. They're not in my VCarve Pro 11 folder. So if I go into here, I should be able to go in through my Vectric local folders. This PC, C drive, users, public documents, Vectric files, clip art, domes and dishes. And I should be able to take that folder and add it to the library here. All right, so now I've got it in the library. Okay, so in here, depending on how deep I want that finger groove and stuff, you know, it really kind of depends. But I am going to use kind of a 60-degree dome. Okay. And I am going to size it down a little bit, you know, to be somewhat appropriate in size. And I am going to stretch it out a bit. Okay. And I want, the biggest thing is I want the end of this dome to be right on my vector line here. Okay, that's going to be most important to me. And the edges, I want them to be as close to the, you know, this size as possible, right? And everything. And all, so I get a nice smooth transition and all, and everything. Because this, you know, it comes down to that deep hole and then it comes up. So if I look at this in the 3D view, okay, right now it's a dome, and I need this to be a dish. So I'm going to go into modeling, and I'm going to go into the properties of this. Sorry, that's not the properties window. I'm going to go into the properties of this, and I'm going to go and change this to a subtract. Okay, a dish, right, if you will. And I'm hoping that I can pretty much just use clipping on my levels here. And if I have this vector selected, I should be able to come in and turn clipping on, or apply clipping, where it cuts off, you know, that. And if I were to throw a zero plane in here, you know, so you can kind of get a realistic view of, bear with me a second. Combine mode, merge. Oh, sorry, I've got to create. Laney, come on now, you know better than this. I got to create a new level because level 1 has the clipping turned on, so it's not going to show anything outside of that clipping. All right, so the zero plane has to be in its own level so you can see kind of a realistic view. And so by doing that, I can create this handle, this cut. Now I don't need it really. I don't think I need it that deep. You know, I don't need it that deep. So I'm going to go into the properties and not of my zero plane. I want to make sure my dish. I'm going to go into the properties and I'm going to reduce the height down dramatically. I just only need it to be, because my board's only 3/4 of an inch thick, right? It can't be 1 inch thick. So I'm going to go 0.3. And everything. All right, let's try that again. 0.3. Okay. And let's see, 0.3. Does that give me enough of a finger grab? If I look at the other photos, right? If I look at these photos, theirs are more kind of oblong. I could have stretched out the oval. I went a little bit more round. But I don't know, maybe 1/2 inch. Let's go back. Let's go a 1/2 inch deep. Yeah, 1/2 inch deep. Okay. All right. And also with that, I'm going to, on my vector, I'm going to change it up a little bit. I'm actually going to have the vector follow the edge. And what I can do to make life easy on myself is I can create a boundary, right, around my model. So it creates the boundary for me. I've got clipping turned on. Let me delete these vectors and show you what I mean. Let me delete this. I've got clipping turned on. If I create the boundary, the vector boundary, it's going to actually draw the vector boundary, right? And now I can use that boundary to my advantage. I can go back into levels and I can reapply or update the clipping, right? First of all, I gotta select the model too. And there is a vector selected. It's right there, buddy row. Okay. It is arguing with me, saying that there's no vector selected, but that is a vector. That is a vector right there. All right, let me make sure it's closed, right? Make sure there's nothing weird about it. That's open. Okay. Back again. Clipping, apply. There we go. So it wouldn't update it, but we'll apply it. So that will be my handle. That's how I'm going to do the handle. I get that nice flat, and I could stretch it out. I could make it look like theirs or whatever. I could figure out, you know, what a good way to do it with just one tool, kind of sweeping it all. But I'm just going to create it like this, right? Here's the problem with that, but though, okay? And this, it's all comes down to time, right? How fast can I make these? Pretty fast on my table saw, my router table. I've got finger joint jigs for my router table. I've got finger joint jigs for my table saw. I've got all these things, right? It's already going to be a little bit longer just doing the finger joints on the CNC. Now I'm adding a 3D carving into this that, you know, is going to take some time too. If I was doing these one-off and everything, might be okay. If I had a big commercial unit where I could run hundreds of inches a minute, might be fine. But on my mid-size unit and everything, where I'm, you know, running, you know, 50 to 60 to 75 inches a minute and things and stuff like that, may not be worth it, right? So I may have to find another alternative for that handle. I don't know what it would be, but right now this is the only solution I have to me with this. So if I were to create this toolpath, it's going to be using the selected vector as the boundary or the model as the boundary, either one, because it's clipped. I'm going to be using a 1/4 inch ball nose bit, the largest bit that I have in my arsenal, which is eluding me right now. Right there. And I'm just going to do a Z-level raster, and we'll calculate that. Actually, that was the wrong bit for the wrong job. I want that to be my 1/4 inch end mill. When I do my finger joints, I want to come over and start carving this as well. So this is the rough cut. It's going to be my 1/4 inch end mill for this one, and this is just going to hog away the waste material and everything. And so imagine, if you will, that I'm over here and it's coming in and cutting the little socket areas, and then it's cutting the handle rough, and then I come back and change bits for my finish cut. Finish butt cut is going to be using my 1/4 inch ball nose bit. Selected vector as a boundary is fine. No boundary offset. And an offset cut for this is fine. It'll be faster. I think it'll be faster. No, raster cut will be faster. calculate that and preview that cut. So that will come in and cut that out. That little handle groove. It's kind of sexy. And it's about 9 minutes on that cut. About 3 minutes on the rough cut. So 9, 10, 11, 12 minutes I've added to that. And then my finger joints are 4 minutes. So total run time on this board, this one board, is about 16 minutes on my machine. So let's assume that that's about right for all 4 boards. Okay, about 16 minutes. And so we're looking at over an hour a box. I don't know. Don't know. You know what I mean? That's one of the things. That's one of the dilemmas when it comes to trying to make money with these things, and stuff. But not bad overall. 16 minutes a board. That's not great. If I was running a bigger machine, I could run much faster. I could knock that down quite a bit. And all, but I don't have a bigger machine, right? I got my mid-sized machine, so we got to do what we got to do. Now, on my end boards, if I was using the end of my table, let's go back to that for a minute. Let's turn on my when you copy your vectors, when I used my vectors to copy them to create these little end pieces and everything, I inadvertently deleted the vectors. I didn't hit the control key, right? So very, very quickly, we're going to change up some things. Let's close this. All right, let's bear with me a second. Cancel that. All right. Edit. Switch this around. 6.625. 0.75. Gadgets. Finger joint gadget. 3 pins. And my interior pins, I want 2 interior pins. 0.625 on the outside pins, 1/4 inch end mill. My clearance is good. I'm actually going to give myself a little less clearance. I'll go 2/1000. And create my finger joints. Rotate them 90 degrees. Go back to my job setup. Change it back around. Oh, can't go that way. Always go through your sheets here. Edit. Change that back around. I had to switch that. I had to 90 degree that bad boy just to just so it'll create the finger joints properly. 625. Okay. All right, let's get those. Let's turn those grid lines off. Let's get those centered. F9 is a keyboard shortcut for center, not for my computer, evidently. I have no idea what I just opened there. F9. Let's stop that. Oh, F9 is like a little tape recorder. Okay, forget that. Let's go back. There we go. We'll just use the alignment tool. Center. All right. Now on this, if I calculate this toolpath, I'm doing a divided cut, so it's going to be much longer on here. So let's look at the times this way. Calculate. All right, so those two Toolpaths for the pins and the socket board, we're looking at about 11 minutes, okay? Per end. Where, you know, 6 minutes on this end, 6 minutes on that end. So I am at 22 minutes per board at this. Now I could increase my speeds and my pass steps. I'm taking 1/8 of an inch per pass. I don't necessarily need to take 6 passes. I could do that, you know, in 4 or 5, and I could shave some time off and stuff and all. But I'll take 1/8 of an inch per pass, and I'm doing it on both sides, so 6 minutes. So 6 and 6 is 12. That's 12 minutes. And then my inner cut, my 3D rough and 3D finish cut, that was, what I say, it was 10 minutes. Here, hold on. It was 3 and 9, so 11 minutes. So 12 and 11 is 6 and 6 is 12 plus 9, 10, 11. Why can't I do the math in my head? 23 minutes. So 16 minutes versus 23 minutes. Doing it on the end, the way my setup is on the end and everything, I'm about 5 minutes more per board, right? So again, something you got to think of. Something you got to compare and think of and all that stuff. But I do have the joint maker jig. I can carve off the edge. I don't have to do the fillets and all that stuff. So it'll make that person happy. Other people might not care. It's going to get painted anyways, so you could pretty much, do that. And I guarantee, I can't guarantee. I was about to say, I guarantee that some of the boxes that he buys off eBay and all, they may cut those on CNC machines, right? Who knows? They may not. I don't know. Now, we're wrapping up here with our frame. So this is the box. Okay, so let's go back really quickly to our front and back sheet here. Okay, let's turn on our layers and all that wonderful jazz. So we've got a dome and a dish with a vector to create the handle, clipping that dish so we only get half of it to create the handles, right? Simple enough. We've got our vectors that we've drawn out with our fillets for our tails and our sockets, our pins and our sockets and stuff. Easy enough. Basically, we just have to do that for the front and back board and the 2 side boards, and our box is done, right? The last thing for each of the boxes is on the very ends of the boxes, on the front and the back, there are what's called the frame supports. And what it is, let's go back and look at our pictures here. And let's look at, not that picture. Let's go back and look at our pictures here. And wish I could do this a different way, but it won't zoom in. File, save as. Okie dokie, tokie dokie. All right, let's zoom in. There we go. Okay, so on the front and back board, there is a notch cut out that the frames sit in. So that notch, for me, once I have all this other fancy stuff done and everything, I can just go over to the table saw and run that notch, right? If I were doing it on the CNC, all on the CNC, then I would have to flip my board over to cut that notch. Or I would route that notch first, flip the board over, then cut the little pocket for the handle and the finger joints if I was carving everything on the table, on the flat table, right? So it's essentially be kind of almost like a two-sided job. That's just a little bit of waste. That's a little. There's other tools in the shop for that, right? If you only have a CNC, then you got to do what you got to do. It's just a rectangle and a pocket cut, okay? But if you have other tools in your shop, router table, whatever, set up a router table with a mortising bit and just run that, mortise and everything, because that one side of the board needs that lip for the frames for the frame supports, for these frames to hook on, like that. And I'm not going to try to copy and paste and zoom that in and all that stuff, but these frame ports, the frame pieces have overhangs that hook on those edges and everything, for the honeycombs and stuff. So there's a little bit of a better view. Can y'all see that? Oh, y'all can see that, right? But here, let's just do this. One more time. File, save as, capture, replace. Go in there and open up capture and zoom in. Okay, so the frame supports sit on that, the frames sit on that frame support, right? So the front and back need that frame support. Now, I'm considering that the front and back, that the hives are running front to back. This is the 16, and this is the this is the 16, and this is the 19 and 7/8. So it's not the front and back, it's the two side pieces that need the groove. The two side pieces that need the groove and everything. Yeah, so I'm not, if I were drawing that in Vectric and everything, basically it would be a rectangle. I don't know. I actually don't know how I'm assuming it's going to be a 1/2 inch. And I'll tell you why I came up with that number. I'm assuming it's going to be a 1/2 inch, but it would be a pocket cut. The depth of cut would be 3/8 of an inch, 0.375. The 1/4 inch end mill, this would be 1/2 inch tall. Calculate, and when we preview the toolpath, it cuts that groove, right? Okay, simple enough. To create that, it's a rabbit, right? But we could also set up our fence on a router table, mortising bit, run that rabbit, or we could set up a dado stack on our table saw, or a single stack, single blade on our table saw, and our fence, just move our fence over and cut that dado. Or we could take a handheld router, palm router, with a little fence clamped to the board and cut that groove. There's so many other ways that we could do it. The CNC doesn't have to do everything. It can do a lot, but it doesn't have to do everything. There's other tools in the shop. Utilize them, right? Hell, if you down to it, you could take a hand saw and cut yourself a little L, a little box, and cut that out. You could take a chisel. There's all kinds of ways, right? So I'm going to leave that one for my router table or my table saw, for those pieces. I'll cut the finger joints, I'll cut the little handle, and that'll be it. Right? Okay. Let's go back to some of the questions here. Let's see here. Wood glue and sawdust, right, Brooks? Wood glue and sawdust. Yeah, we're gluing the part together, so wood glue and sawdust would fill in that nicely. It's going to get painted again, right? So you wouldn't see it. So yeah, wood glue and sawdust would work well. Bondo works great. I use it all the time to cover minor imperfections. Yeah, Camaro. But with the beehives, bees are real sensitive to certain chemicals and things like that. So there's certain things that we can and can't use. The wood glue is actually fine, so maybe the Bondo will be too. I'd have to find out. I'd have to find out from the gentleman, the apiarist. I'd have to find out if if the ingredients in the Bondo would hurt them as far as the scent, the smell, or I don't know. I'm not a bee guy, right? Let's see here. Does Bondo have gas safe for bees, right? Let's see here. How else could you cut the handle hand router? Well, Brooks, that's the thing. I could use a palm router and everything, but I'd be changing my, and there'd be a lot of sanding afterwards. So up here, let me zoom in here. With the palm router, I'd be at my deepest cut, back and forth. But then I'd have to keep changing the size of the base, bringing the bit up into the base more and more, because I'm getting shallower and shallower and shallower and shallower. It would look basically something like this if I look at the rough cut, right? But not the stair steps here. I'd go deeper, but then I'm going to be taking it shallower and shallower and shallower and everything. And then I could do it a little bit tighter than that. That's some 1/8 inch steps there and all. But then you would sand it in, right? Depending on, you could use a bowl and tray bit. You could use a cove bit. So let's look at, it's been a while since I've looked at a cove bit. Bear with me just a second. It wouldn't be a box core bit. Let me look at a cove bit. And let's see here. Definitely would not have a bearing. This Yannica bit, without the bearing, guys, without the bearing, a standard box core bit would probably work. And I could, cut the groove. I don't know. I mean, I know, but for some reason I can't picture it in my head right now. What bit I would use with a handheld router. Because it's got to have that flat edge on it. That one I'm not sure of, bud. I don't know what other method. I could do it on my table saw. Just like doing a cove cut, but that wouldn't work either. Yeah, some of the other woodworkers and all throw out some ideas there on that one, but essentially we've got to cut, a place for the handle here, and then, cut it out. Right? You could do it with a handheld router, right? It doesn't have to spoon. It's fancy. Where it comes to a smooth, finish here and all, but it could just be a pocket cut, a groove where you could get your fingers in there. Something, right? When we, with the, the smoothness and everything, it, it kind of smooths everything out to that nice transition, right? So how could I get that? How could I achieve that cut freehand? That'd be a tough one. I don't know. I don't know. I don't know. Yeah, honestly, I'm actually stumped on that one. I don't know. Yeah. I don't know why I'm stumped, but I am stumped. All right, so let's go back here. Now, let's take a quick look at the, I'm going to save this file, save as, or save. And let's take a quick look at our other sheet. Let's come back in here. Sheet 1, the one that started it all. And let's look at our frames. So there's specific sizes for frames. The medium frame for the medium box, you got deep, shallow, or medium. The medium frame for the medium box is 19 inches in length, and it's 6¼ inches tall. So there's about a half inch. No, a half inch plus an eighth is 5/8. Hold on. There's about 6 5/8 is my overall box size. 6¼ is my frame size. 1/4 to 5/8 is 3/8. Holy cow, Lainey, you are getting dense tonight. Let me see here. I got to actually cheat on this one. 6.625 minus 6.25 equals 3/8. Yeah, I couldn't. Why am I not seeing things the way I want to see things? All right, so that's our overall frame height. 6¼ So that gives us 3/8 of an inch of room. 3/8 of an inch of room, and it's precise. You don't want a whole lot of room in these hives. For them to create other kind of, you want to, yeah. Anyway, I'm not, he tried to explain it to me, but it's very tough. So the frame sides here, they are 1 3/8 inches wide at the top, 1 1/8 inches wide at the bottom. Okay. The overall length is 6¼ Okay. 6¼ top to bottom. That's the overall height. And then it's 1 3/8 at the top, and then it tapers down to 1 1/8 at the bottom. Now, the measurement, the specific measurement on this, let's go horizontal, from the bottom of the frame piece, the frame side, to the top of this little 45-degree taper here, it's 3 5/8. Okay, and then from here to the top of that taper is 2 5/8, right? So the overall is your 6¼ Okay, 6¼ Now, when I drew this this rectangle here, basically I measured up following the plans, 3 5/8, and then I drew a 45-degree line in and made sure this inner rectangle here. I'll just draw one out. You can see exactly how I made it. So here was my drawing. So rectangle 6.25. That's the overall. Height 1.375. That's the width. Apply. Okay. Rectangle. Oops. Rectangle. This one is 1.125, 1 1/8 by 3.625. Okay. That rectangle snaps to the center of that rectangle. Okay. Now, that 3.625 is at the top of the 45-degree line here. So that 45-degree line actually starts here and then comes down. So take a line. I'm going to draw a line from here straight up 90 degrees. And then I'm just going to take a line literally 45 degrees. Oh, don't do that. Undo. 45. Let me find my 45 right there. Snap a line. Okay. Come over here. 45 degrees. Snap it there. And then take up some scissors and trim that away. Trim that away. You know, and that creates the main piece, right, of the frame. Okay. Now, here, on this area here, we've got a rectangle that is going to be 7/8 of an inch wide, and it's going to be 7/16 of an inch deep. Okay, 7/16 of an inch deep. So basically, we'll just snap that right there. And this one is going to be this rectangle is oh Lord have mercy, undo, 3/8 of an inch wide by 3/4 of, or 3/8 of an inch deep, sorry, 3/8 of an inch deep by 3/4 of an inch wide. And that will go here. Right? Now, if I take this end and just bring it out there a little bit, and if I take this end and bring it out here a little bit, then I can use my scissor tool to, you know, trim and create that part. Right? And then as far as the holes, this is where the fishing line filament, the wax or the plastic or wax honeycomb goes in the middle. That's kind of the starter. And then there's, you can either use wire or fishing line filament to hold this thing in place and everything. And the 3 holes, they're just randomly kind of eyeball, you know, wherever you want them. And they're 1/8 of an inch in diameter, you know, so I'll just kind of snap them there, right? And so that's a frame side, right? Now what they do is they take imagine that this is a 2x6, right? Okay. They take and their part 1 3/8, they're 1.5 inch wide, right? A 2x6, 1.5 inches wide. Well, this part is only 1 3/8, so there's a 1/16 that's going to get milled off this. But they run this through the table saw or router table, and they cut that bottom notch in there, and then the top, they cut the top, you know, they flip it over, and then they cut the top notch in there and everything. And then over on a bandsaw or whatever, they come and slice this thing into 3/8 of an inch wide pieces, and they can get a ton of side pieces for frames. If they're knocking out frames, right, they're getting a ton out of that 2x6, right? Well, I'm doing just kind of a one-off on a board laying flat, you know, so I'm trying to cut these parts out of a board laying flat and everything. Okay, so doing it with a router table or by hand or whatever, that's gonna be not more proficient. Well, I mean, in a way, kind of more proficient, because they can knock out quite a lot of pieces in one go, right? And and everything. So, you know, this isn't going to be probably the best method to go, but it's the method we have. So this part, once it's drawn, then it comes over and it's going to get mirrored, you know, flipped to the other side, and that's going to be the other part of the frame. And, you know, those 2 parts are done. Okay. Now, there are, for the top rail, there are 2 different types of top rails. There's one that's a center groove rail, and it's for the plastic honeycomb starters. And then there's another one where 1/2 of the board gets milled away, and it's for the real honeycomb, the wax ones, the wax honeycombs. And it's got a trap board in there. Again, I don't know all these parts and all this stuff, but the design I laid out here is for the second, for the wax combs. And basically what we've got here, let me see if I can hold down the control key. Let me drag this out. All right, so we have our top part here has an overall length of 19 inches. Okay. It has a overall width of 1 1/16 inches wide. Okay. The notches here, right? This notch actually slides up into this groove. Now this groove has those fillets in there because it is getting carved on the table, right? Has those fillets in there. That's why it looks weird. It's a rectangle with those fillets and stuff in there. But the from the end of the board to the start of the groove, it's 5/8 of an inch. Sorry, that was a lie. From the oh, Lord of mercy. I'll get the measurement here right in just a minute. It would help if I go horizontal. From here to here. Yeah, from here to there. I was right the first time. No, it wasn't. All right, now. Hold on a second there. From there to there. 5/8. Yeah, I was right. I was just grabbing it in the wrong spot. So from the end of the board, 5/8 inches in, we have a notch that is 3/8 of an inch wide by 3/32 of an inch deep. So from here to here, 0.0889, 3/32 of an inch deep. And sorry, my mouth is getting dry. And that's the same on both ends. Now, since the router bit, I'm using an 1/8 inch bit now for this. This part's getting cut out with an 1/8 inch end mill. But since a 1/8 inch bit is getting cut, this is going to be a 1/16 of an inch dog bone fillet, so that the router has a place to go and it creates this flat spot, so that my little side pieces, these little guys right here, they will fit into here. Something along that lines, but not that wide sticking out. They will actually stick out probably about like that on both sides. So let me get everything lined up. So imagine, if you will, and I don't know why I just did that. Let's go back there and snap you back there. Like a fork, right? Comes in a bridle joint, if you will, in a sense, right? And then they stick a pin nail right there. Okay. Now, on this groove, the Toolpaths for this, basically, we have, let's go to our sheet 1 here. We have a fluting toolpath on the very ends. The very ends have this little upward taper. Okay. It goes from, at the 5/8 inch mark back to the end of the board, it goes from a 1/2 inch to 7/16. So on the very ends, it's 7/16, and then it's got this taper to a 1/2 inch. And so that is a fluting toolpath. I drew the lines, and since all this is getting milled away right here, the lines can start kind of back a little bit, and it's going to cut from a 1/2 inch to 7/16. So I'm starting at a 1/4 of an inch down, because the 1/2 inch is from the top of the board. Imagine it being flipped over. So from the top of the board, that material is a 1/2 inch. My board's 3/4, right? So I need to mill down a 1/4 of an inch, and then I need that'll take me to the 1/2 inch mark. From the bottom up, it's 1/2 inch. And then I need to take a 1/16 of an inch off. It's a 1 in 10 incline in a sense. But I'm taking a 1/16 of an inch off. So I'm starting at a 1/4 of an inch down, and I'm milling 1/16 of an inch off, and I'm ramping with an 1/8 inch bit over the entire length of this line. So when we carve it, Let me see if I can zoom in here. See if I can get it to spin around a little bit. When we carve it, it's going to create this taper. So from a 1/2 inch down to 7/16. Okay, you can't tell right now because you can't see everything. We're gonna fix that here in just a minute. Now there's also a 1/8 inch, or a pocket cut, if you will. There's also a pocket cut that is coming in and removing this part here. So the first thing I'm going to do before I do anything is I'm going to recalculate all of my toolpaths on this board here, because some things got moved around and stuff. And of course I didn't realize it was going to recalculate all the toolpaths. Okay. So coming back to my fluting toolpath here, that's going to do the little recess. I'll show you that in just a second. There is a profile cut that gets cut last, but there's a pocket cut that is going to cut down 1/4 inch. And again, using an 1/8 inch end mill, and it's on only half of the board. So if we preview that toolpath, okay, it's going to mill away half of that. Okay. Then there is a profile cut. Again, it'll be last, but let me do it right now so we can just see the profile, and I can get rid of the waste material. Okay. So you can kind of see what this frame piece starts to look like. Now, on this frame piece, right here at this notch, okay, the sides are cut in 3/32, and the top is cut down, right here is cut down 1/4. And so that cut, if we preview that, that kind of cleans up this end here and everything. So it just basically cleans that up. And if we look at this, let me see if I can get a side view of it. Which view? Which view? Which view? There we go. So that first fluting cut takes the part here, and it takes it from a 1/2 inch down to 7/16. So this is 7/16 inch thick, right? So they're doing this normally on a table saw, or this part on a bandsaw, but they're cutting their little notches. They're running a rabbit cut to cut that little groove. And then they're on a bandsaw, they're doing that little 1/16 inch. They got kind of a tapering jig, and they're cutting the little tapers on the end. Again, a part they could knock out very quickly using the table saw and the bandsaw. I want to do it on the CNC. So these are the vectors that are required. We have our profile cut vector. We have our pocket that removes half of that piece where the wax sits up against. And then we have our little chamfers on the end of the profile, the little chamfers, and our fluting. So that's the toolpath for that part. Now the bottom board's really straightforward. It just has a groove going right down the middle. Let's reset this preview. And this. Let me get everybody back on track here. Let me get my vectors going. that vector. Oh, ungroup. That's what happened. I grouped everything together and it screwed it up. Calculate. And this vector. Calculate. This one. Calculate. Okay, so on here, the bottom piece is only 3/8 of an inch thick, right? Now here's where I think I'm going to make a change to this frame. But if we look at all the parts, preview, 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 preview. Visible toolpaths. Let me cut out all these parts. Okay. This is our top and bottom frame. The bottom frame is just a 3/8 of an inch thick, 3/4 of an inch wide with an 1/8 inch groove down the middle of it, right? That's all there is to the bottom piece. And it fits into the bottom notch right here, right? Pin, nail, glue, and that's your frame. Well, here's the thing. In order to get this 3/4 inch board down to a 3/8 inch board, and everything, here, let me see. Hold on. Let me see how deep this is. Measure horizontally from here to here. 7/16. So I have a 3/4 inch board. This top piece, right, is 3/4 of an inch thick, but right here in the pockets it's milled down to that 1/2 inch. So it sits a little proud for some reason. I'm not sure why, but we'll figure that one out. This is 3/8 of an inch, and these parts are 3/8 of an inch. So I have different size parts or different thickness parts on this, and it's going to require me to do a pocket cut. So what I've got going on here is on this bottom piece, I've got a pocket cut that is taking off 3/8 of an inch. Then I have a profile cut that is doing an 1/8 inch bit to cut that groove. And then I have another profile cut that is cutting the part out, right? So essentially I'm wasting 3/8 of an inch of wood for not only this part, but I'm also wasting it for these parts because I'm having to mill those, pocket those down 3/8 of an inch to get a 3/8 of an inch piece out of it, right? Well, for me, I think that instead of 3/8, I make it 5/16. You know, each of these are going to be 5/16 of an inch thick, which means my notches change here to 5/16 because I want a nice tight fit and everything. I can carve those, right? I could literally kind of do one, and then I could run it through a bandsaw with my thin curved blade. It's going to be, you know, what have you. I don't think my blade is an 1/8 inch thick. I don't know how thick my kerf of my blade is. I'll have to figure that out. But if I take that 3/4 inch board and I now resaw it, those two parts in half, now I've got the two sides of my frame, right? So, and this, unfortunately, because of this groove right here, if I take this board here and I resawed that, you know, to my thickness, my groove has got to go into one side or the other. I can't run the groove on the CNC and then resaw it. It doesn't work that way. It'd have to be a two-sided job where there's a groove on one side, a groove on the other, and it gets resawed in the middle. Or I resaw those parts and then I just run them through the table saw and cut the groove in them, right? So what's going to be faster? You know, what's going to be faster? Is this something? This is, I mean, it's a square piece. God almighty, if I can't cut a square piece and I need a CNC to do that, I'm in trouble, right? So might be easier just to cut that on the table saw. But this, I could essentially, if I cut this piece on the table saw and eliminate it, I could essentially take and double this piece up. So now I have 2 frames here. I could still use these 2 vectors here and cut them out. And when I resaw them, I have 4 pieces now, 1 for each end of the frame. And then my bottom piece, I can cut out of another, scrap board, resaw it to 3/8 of an inch thick and cut my groove down the middle. And then I've got 2 frames out of 1, right? I don't know. All this stuff this is in my design process on how am I going to do this on the CNC. This is where this is the thought process that goes into it in my head. It might be easy for you to be like, nah, I'm just going to do it on the table saw or the bandsaw, right? I'm trying to figure out, okay, I want to do it on the CNC because the guy wants to see it done on the CNC. So all of this stuff comes into play. How can I not waste so much wood? Why would I want to pocket away 3/8 of an inch of material just to get a 3/8 of an inch part out of a board, right? I don't. I would much rather reduce the size to 5/16. That gives me, a 1/16 and a 16th and an 1/8 of an inch of waste, right? And I can, resaw that, and my bandsaw is not an 1/8 of an inch thick. My bandsaw blade is not an 1/8 of an inch thick, so I can pretty much, I'll do the math and figure out what, after it's resawed, what the 2 halves are. They need to be exact, right? I don't want to have to sand them down to an 1/8 of an inch thick. God forbid, right? Or 3, to 5/16 of an inch thick. I don't want to have to sand them down. I want to be able to either one cut and done. If I run them through my table saw blade is an 1/8 of an inch, and I can get 2 perfect 5/16 out of it, right? That kind of deal. It really all depends, but I want to be proficient and not waste wood. Why mill it away when I could use it, kind of thing. So that's the stuff I got to think about. I know this is all boring to you and everything, but these are the things that I'm just showing you kind of when you're prototyping, right? This is a prototype project. I've never made one before. I'm prototyping it to see what's going to be. I'm going to cut one and make one on the CNC. And then I need to look at, for my production, if this is something I'm going to knock out and sell. Because some of these boxes are selling for $200 a pop. Hold on. I'll show you. I'm not joking. Let's see here. Beehive boxes. Okay. Let's come over here. Okay. Depending on, how many boxes and what size they are and everything, medium size box and stuff, $54 and things like that. A 3-tier box, $209. One of the boxes, the medium boxes that were, $52. And that's what this guy's paying. He's saying, sometimes I can get it for this, sometimes I can get it for that, and all that stuff. And he said, I wouldn't mind paying you at all. I'd buy my Beehives from you if you made them, right? So, there's potential. I mean, here's a 3-tier box made of cedar, whatever. I don't know if that's made of cedar, but usually pine. Usually it's pine. $379, right? So the boxes, anywhere from, for one single box, $34 up to $300. What's going to be the most proficient way to me to knock out the crap out of these things? And, I'll sell them to him for $300 a piece, right? Do bees come with the boxes? No, he gets his bees from, it's so cool. He's got videos and everything, but people call him to remove beehives. And so he'll walk in there. He doesn't walk in with any gear on except for his headgear. And he'll grab the hive and he'll take it over to the box and he'll find the queen. He'll get the queen in their little capsule and put it into the beehive box, the medium box. And then he'll sit there and wait, all the bees flying around him. And he smoked them a little bit, to stun him a little so he doesn't get stung too much. He gets hit like 4 or 5 times, he said. But And then it could take hours. It could take a while for all the bees to transition into their new home. And then he closes up the box and he puts it in his farm, right? His little bee farm and stuff. It's a crazy thing, right? But they're buying their if they're not making their boxes, they're buying their boxes and stuff. And some of the Beehive boxes, some people have gone crazy, like where they're actually on the Beehive box, like on Etsy here, where and no offense, little Laura Aprey, but the screws on the finger joints just tear. It breaks my heart. But you know, they're doing 3D carvings of bees, and people at $98, right? You know, people are buying that. But yeah, don't screw your finger joints together. Some people are getting fancy with you know, carving the honeycombs and all. That's where the CNC comes in. $100, and you know, they're, you know, 670 reviews, 4.9 stars, 5,851 sales, right? You know, come on. So I mean, medium-sized box from T Texas Bee Supplies, finger joint, what we're talking about right here. And again, they've stapled the finger joints. Frig me. Okay, as a woodworker, that breaks my heart. But you know, assembled, unfinished, you know, $64.30, right? That kind of deal. So with you know, 10 frame medium box, right? And I don't know if are the frames included. Let's see here. Be ready for the fully assembled 10 frame. Our kits are made with pine. They're stapled for added strength. Comes complete, fully assembled, and so I'm assuming the frames come with it, right? $64. But anyway, long story short, evidently there's money in beekeeping, right? Or selling Beehive boxes and stuff. So, hey, you know, I am going to lay out the files all nice and clean and everything, and then I will make them available. I will make the finger joint jig available to the download in this video. And who knows? It could be something that you add to your arsenal of tools, but do it as a prototype and then think about how you would actually do it to, if you wanted to, like, fast production, rock it in, you know, $64 a pop, you know, what's it going to cost me? Or $100 a pop, what's it going to, you know, time. Right now on the box frame itself, we're at 22 minutes a box, right? Or 22 minutes a side, a board, right? Was that right? Hold on. What was my time? 21 minutes. Yeah, per board. So times 4. I mean, you know what I mean? So that's what you gotta. It's not 21 minutes. It's 16 minutes. 16 times 4. So you're talking about an hour, right? Times money kind of deal. And yeah, and they're open on the bottom. There's no bottom. It's just 4 sides and then the frames, right? Crazy. But so maybe it might be something that you could, you know, get out of it. I'll create the files and you'll have them. You need to find Lainey, you just need to find a suit and queen. I need to find a suit and queen. Yeah. But whether you cut it on the table, whether you cut it on something like an in cutting jig, you know, if your router can go off the front of your table, there's all kinds of ways to come up with things. I wanted to share this with you and see what your thoughts were, and maybe make something thought provoking, like when you're prototyping stuff. It could be anything, you know, that you're prototyping, parts and all, how they fit together. How can I maximize? How can I minimize? what's going to be better to be done on the router table or the table saw or the bandsaw versus the CNC. But, you know, I will make these on the CNC. I will prototype all the parts on the CNC, and I'll get everything, you know, nice and together. And then I'll look at, if I were going to make these for this guy and sell them, I'll make the money. You know, it doesn't bother me one bit. It's just pine wood. I can knock out a few of these. A little extra money doesn't hurt. But I've already got to buy. He's dedicated. He's a buyer. He's like, you make them, I'll buy them. Right? As many as I can make, he'll buy. Put it that way. And he's got big acreage. The boy's got money. I know he's got money. He's got big acreage. Because I go to his, you know, he's got a gun range and everything out in his property and all that stuff. You know, so he's got the money. But long story short, hopefully that will do. Hopefully this maybe give you something to provoke your thoughts and all that stuff. And it's pretty easy to lay out. The dimensions and everything for a box, some of the sources that I used, CompleteBeehives.com. They have 3 box sizes: shallow, medium, and deep. It's common all the way across the board. So that's the 16 by 19 and 7/8 by 6 and 5/8 for a medium box. The medium box are sometimes the more popular ones because of the weight. After all the honey and the honeycombs and everything are in there, they get heavy, and people, depending on how high they stack these things, right, depends on the weight that they can handle. And some people just go with the medium box because it's a pretty moderate weight that they can handle per box when they're full of honey and all that stuff, when they're harvesting and all, so less damage of the bees. You know, that's where those dimensions come from. And then other resources, you know, were the bees-and-beekeeping.com, build a beehive, right? Step-by-step instructions to, you know, build a beehive. You know, all the different components of a 2-tier beehive box, right? They don't have any dimensions in here, you know, not a single dimension. They got pictures, right? So you got to go off the pictures, but then you can find the dimensions everywhere else. I'm going to lay these parts out into a nice organized fashion. The Vectors 2, SVG and DXF. For those of you that do not have version 11, you'll be able to download the vector files as well. Hey, maybe it'll be something you might get into beekeeping. All right. So Kool-Aid, do they stain them or use certain kind of woods? Okay, so no stain or anything. It's usually just white paint. It's usually just painted white. They paint them just to kind of weather protect them and stuff. But it's pine. For the frames and all, you want kind of you want to cut around any defects, but it's just knotty number 2 pine. They're all they're using. Not pressure treated or anything like that. Absolutely not. No chemicals or anything. It's just regular pine. Now for me, I'm going to make his boxes pretty nice, so I'm going to use Select Pine. It's a little bit more expensive, but it's defect free. So I will be making this particular box, this prototype and stuff, out of the Select Pine and all. But it's just they paint them, right? So just regular white paint and that's it. So I've seen some, you know, when we're looking online at the different, it's mostly all pine, aged pine and all that stuff. And again, shallow, medium, deep boxes, and the medium boxes are kind of more popular, but they stack them, right? So the deep ones will kind of be down, and then the medium ones and all that stuff. And again, depending on how much weight, I mean, these stacks could be, you could have tall systems and all that stuff. I mean, all on these colonies and everything, but just depending on how much weight. So for him, he likes the medium size boxes. That's all he gets is the medium size boxes and everything. But I mean, it's an interesting thing for sure. But dimensions are all over the place. I mean, you just type in Beehive boxes and there's dimensions everywhere and stuff. One of the dimensions just to show you, I'll include this in here as well. See if I can open that up. Is basically the frame side pieces based on if it's a deep, medium, or shallow box. The dimensions are different, right? And you can almost screenshot this if you will. But I'll include that in the files somewhere, you know, so you know the different size pieces for the frame pieces depending on which box you're doing, right? And also the size of the boxes themselves, medium, shallow, deep. They're all, just put it this way, to make it as simple as possible. They're all 16 by 19 and 7/8. The width of your board depends on, you know, if it's a shallow box, it's 5 and 7/8. If it's a medium box, it's 6 and 5/8. And if it's a deep box, it's 9 and 5/8. Right? So that's the only thing. That's the only difference. All the box sizes are all the same size. The depth of the boxes make it a shallow, medium, or large, right? Or deep, not large, deep. Shallow, medium, or deep. Right? So cool stuff. Apiaries, apirists, right? Beekeepers. They need beehives. We have wood. Let's make them some beehives and make some money on top of it. All right, everybody. It is 9:51. We're going to go ahead and I'm going to see if there's any last minute questions you have for me, and then we're going to wrap it up. Let's see here. The shallow or not used much, Mickey says. That's what I come to find out from him. He doesn't like the shallow. He likes the medium. They're kind of the perfect fit for him. So shallow aren't used much. So that's something to keep in mind mentally. Let's see here. The deep and mediums mostly, Mickey. Thanks, Mickey. I appreciate that. Do you bear, gentle bend, protect them? Do you bear, gentle bend, protect them? Brooks, do you protect them from like bears? Like, you know, coming to get the honey? I don't know how that works. Let's see here. Thanks, Lane. A lot of good learning. Kool-Aid, mostly use pine, paint, some woods, weather resistant. Okay, let's see here. Might be faster to CNC router jigs to cut certain parts. Make your jigs with your CNC, taper jig, all that good stuff. See, there you. Now we're thinking. Make a beehive. I'm gonna make a beehive. I'm gonna make a video and I'm gonna record it. Let's see here. Yep, paint them white to reflect from the sun. Very good. On my machine, I can clamp 4 sides together and cut them on the end. There you go, Ron. Awesome. And I probably could too. My bit can go out 3 inches past the end of my table. My jig, I could probably do 2 boards stacked on top of each other if I wanted to. Let's see here. Thanks, Laney. Everyone. Hope everyone had a good day. And how's the new building going? Blue Knight. It is not. The material, they're still months out from even getting to me. You know, it's not. Foundations, it's just not. So I'm working in my small shed until things get a moving. Oh, hey, just some news. It's not my life story. I wrecked my Lexus. I wrecked my car last week. Oh, totally damaged.
I couldn't find a list called car.
Alexa, I'm not talking to you.
Sorry.
I know.
I thought I heard my name.
I know you didn't. I said Alexis. The arguing with an AI. Yeah, got in a car wreck. Can you believe that? Let's see here. Nobody was hurt. Little scratch on their bumper, crushed my whole front end in. Thanks, Lexus. All right, let's see here. All right. Yeah. So we are good to go. We're going to wrap up. I'm going to show you one last thing and then we're going to say goodbye. So let me show you here. Where's it at? Get to it. I don't have, let's see here. Come on now. People are waiting on you. Hurry up. All right, let's see. Oh, isn't that heartbreaking? A little scratch on their plastic bumper. My whole front end caved in. Isn't that something? All right, everybody. Thanks for hanging out. Until next time, we will see you soon. I appreciate y'all. Have a great night.